Yeah, it is a timed quiz, so you have to take it during the class times. So the quiz will start at 11:45 a.m. and it will end at 12:20 p.m. So you'll have actually total 35 minutes. So the quiz time is 30 minutes, and I gave you 5 minutes extra because you need to log into my lab statistics. So it might take some time. So that's why I'll give you 35 minutes. Okay. Any other question? Yes, there is 4 questions. 2 from chapter 7 and 2 from chapter 8. Okay, so in the last class we started hypothesis test for one population mean. So in hypothesis we have null hypothesis and alternative hypothesis. Okay, so there are 3 type of hypothesis test. So and it depends on our hypothesis. So the first one is left tail test, and the second one is right tail, and third one is two tail test. So how do we determine the tail of the test? And what does it mean by the tail of the test? So in hypothesis, since this is the hypothesis testing for one population mean, so our null hypothesis will be mu is equal a fixed value or a particular value of mu, which is called mu0. So this is always fixed. So the null hypothesis will be always like this. Mu is equal, the mean equal, since this is for one population mean, because we want to test whether this mean is equal some value or whether this one is greater than this one, or whether mu is less than this one, or whether mu is different from this one. So we want to actually test these 3 cases. The first one is the population mean is less than a fixed specific value, and the population mean is different from a specific value, and the population mean is greater than a specific value. So we want to actually test this. And this hypothesis will determine the tail of the test. And null hypothesis is always equal, mu is equal of the fixed value. So this value is called mu0, which is also called hypothesized value. Okay. So it could be 0 or it could be some other values. Okay. And the alternative is this is either less than this one. So if we have a hypothesis like this, then this hypothesis test will be called left tail hypothesis test, because this is less than time. Because in this case, actually, the critical value will be somewhere here on the left side of the distribution. So that's why we call this one as left tail test. Okay, so left tail. So that's mean the null will be mu is equal mu0, and alternative is mu less than mu0. Then the right tail test is mu is equal mu0, and alternative is mu greater than mu0. So if you have a hypothesis test like this, if your null hypothesis is like this and alternative is mu greater than mu0, then it will be called right tail test. So we have one more test which is called mu h0 is mu is equal mu0, and alternative is mu is different from mu0. So that's mean we just want to see whether the population mean is different from this specific value or not. That's the purpose of this hypothesis test. This is called two-tailed test. Why two-tailed? Because mu could be less than mu naught, or mu could be also greater than mu naught. So that's mean we have both tail here. So that's why this is called two-tailed tests. So we have three type of hypothesis test. First one is one tail, sorry, left tail, and right tail, and two tail. So the left tail and right tail test are called one tail test. Do you have any question? Now, the question is, how do we perform the hypothesis test? So to perform a hypothesis test, first you need to write down your hypothesis. So that's mean mu is equals to mu0, and you need to write the null hypothesis and the alternative hypothesis. Okay, thank you. So first you need to write the null hypothesis, which will be always like this. Actually, there is also like composite null hypothesis, but we are not going to cover the composite null hypothesis in this class. So we can also have this. Is it also possible that the null hypothesis could be mu less than mu0? But we are not going to cover this one in this course. Okay. So in this course, we will always consider mu is equal this one. And if you have this type of null hypothesis, they are called composite null hypothesis, but we're not going to cover this one here. Okay, so first thing is you need to write the hypothesis. That's mean you need to write the null hypothesis and the alternative hypothesis. So this is called null, and this one is alternative. First, you need to determine these two hypotheses. Then you will collect the data. So you will use the data. And after collecting the data, you're not going to collect. So you will be provided the data. So you have to use the data and calculate the test statistics. So what is test statistics? For example, here we want to do hypothesis test about mean, right? So what is the point estimate for mu? So how do we estimate mu with a single value? Anyone? What is the point estimate of mu? So till now we learned two estimates of mu, right? One is point estimate and the other one is interval estimate, right? The interval estimate is the confidence interval for mu. So what is the point estimate for mu? Anyone? Okay, margin of error. Okay. Think about this like this way. So for example, we want to know the average height of the US population, the average height of US adults. So we collected a sample from the US adults. That means we selected maybe 100 peoples, 100 adults, and we measured their heights. So how do we make inference about the average height of the total US adults? So do we calculate standard deviation or sample mean or margin of error or confidence interval? So which one will be using to make inference about the average height of the total US adults. Yes, point estimate, yeah, it will be the sample mean. Yeah, that's correct. So we calculate the sample mean and we use that one to make inference about the population mean, right? So that's why the point estimate for mu is sample mean. So that's mean X bar. Okay, so what is the test statistics? Test statistics is, it will depend actually. So for confidence interval, we had like, we calculate the confidence interval using two distributions, two type of confidence interval. One is Z interval and the other one is T interval. So it will depend on the assumption, right? So for Z interval, we needed some assumption, 3 assumptions. And for T interval, we also needed 3 assumptions. And similarly, for a hypothesis test, we'll have some assumption. And based on this assumption, we'll perform the hypothesis test. So for one population mean, we can also have either Z test or we can also have T test. So we can do either one of them. But it depends on the data. So if the sample come from normal distribution, that's mean if the population distribution is normal distribution, so in that case, whether the sample size is large or small, it doesn't matter. And if sigma is known, then we'll use Z test. But if sigma is unknown, it's actually similar to the confidence interval. So we had some assumptions for Z interval, and we have also had some assumptions for T interval. So we'll have the, for hypothesis test, we'll also have the same assumptions. Basically, the hypothesis test and the confidence interval, they will give us the same results. Same results mean we'll have exactly the same inference about the parameters from the hypothesis test and confidence interval. Okay, so I'll talk about this later. Yeah. So for Z test, we need to calculate the test statistics. So how do we calculate the test statistics? Okay, for Z test, the test statistics will be Z is equal X bar minus mu divided by sigma over square root of n. Okay, so this is the Z score, right, for X bar. So test statistics, for test statistics, we had, sorry, for hypothesis test, we had two hypotheses, right? One is mu is equals to 0, and the other one is mu is different from 0 for two-tailed test, or it could be also mu less than mu 0 or mu greater than either of these three. So it could be maybe this one or this one or this one. Okay, let's consider the alternative is this one. Okay, mu less than mu 0. So what we are doing here in null, we are assuming that mu is equal mu 0. So this is our assumption. We are assuming this is true. Now we'll test based on our data. So based on our data, we will calculate the test statistics, and based on the test statistics, we'll make our decisions. So in this test, we can have two decisions. One is either we'll reject the null hypothesis in favor of alternative, or we'll fail to reject the null. We'll fail to reject the null hypothesis. Okay. So what is test statistics? So this is the Z-score for X bar. Now we are assuming in the null mu is equals to mu 0. So to calculate the test statistics, we'll assume the null hypothesis is true. Then we'll get a value here. So that will be the Z-score. This is called Z observed. That means it will come from our observed data. or you can also say just Z. Yeah, that's fine. Okay, so now we have that this is called test statistic. So how do we make our decision? Okay, we'll discuss this one in the next section. So there are two approaches. One is called critical value and the other one is called p-value approach. Okay, so we'll discuss this one in the next section, section 9.2. Okay, so based our decision, so we have two decisions. One is we can reject the null in favor of alternative, or we can fail to reject the null. So we'll make this decision based on the data we will collect, right? So the problem is when we'll make our decision based on the data, since we are making decision based on the sample data, so there is chance that because for different sample we can have different results, right? Because when we collect different samples, we'll have different values, and we can, so since the sample is not equal to the exactly equal to the population, right? So for different sample we'll have different values, and based on these values we'll make our decision. So there is chance that if the sample is not like very representative, very good representative sample, then there is chance that we might make wrong decision, right? For example, so in our class we have 134 students. So we want to know the class average in the first test. So we didn't ask all the students. We just selected 10 students from here and we asked about their score and we calculated the average. For example, if we somehow select 10 students whose scores are, maybe all of them got 100. What will be the average score then? Average score will be, average score will be then 100, right? X bar will be then 100. Yeah. But the actual average was, our class average was, the population mean was 80, I think, yeah, it's not 82, 80 point something, maybe 80.5. So now based on this class average, this sample average, if we make decision that the class average is above 90. So for example, we want to do this hypothesis test, whether this is, we want to do this test above 90. So based on this, sample, if we make decision, then our decision will be, we'll reject the null, right? Because we'll support this one, because mu is greater than 90. Yeah, our data is supporting this one. So that's mean our decision will be mu is greater than 90, but which is not true, right? The actual average is 80.5. So that's mean when we do hypothesis test, we make inference or we make decision based on the sample data, right? So that's mean there is a chance that we might do some mistake. So now it depends, like we will determine or we'll fix before doing the hypothesis test how much error we want to make. They are called type 1 error or type 2 error. So there are two type of errors, type 1 error and type 2 error. So before doing any hypothesis test, first we'll fix the type 1 error, probability of type 1 error. That's mean how much type 1 error we want to make. So first we'll determine this one, then we'll do the hypothesis test. Okay, so we also discussed this one in the last class, but I want to discuss it again because this is really important to understand. Okay, so when we'll make decision, there are 4 scenarios. Okay, maybe this is our decision based on the test, and this is true fact. true fact. Okay, so age is true, age is not true, or maybe age is false. Okay, whatever it is. So our decision is we'll either reject null or fail to reject null. Okay, so when null is true and we reject null, so that's mean our decision is wrong, right? This is incorrect decision. So we are rejecting null when null is true. So that's mean this is incorrect decision. This one is called type 1 error. So when the null is true and we reject null, this is error, right? Because null is true. So we are supposed to accept the null, not rejecting the null. But we are rejecting the null when null is true. So that's when this is an error. This will be called type 1 error. So when null is true, we fail to reject null. Yeah, null is true. So that's mean we shouldn't reject null. And that's what we are doing. So this is correct decision. And here, excuse me. So null is not true, null is false, and we fail to reject null. So this is also correct decision. So here, null is not true. So that's mean we should reject the null, but we didn't reject the null here. So we failed to reject the null here. So that's mean this is called type 2 error. So sometimes type 1 error is more serious. So in that case, the probability of type 1 error is alpha and probability of type 2 error is beta. So before doing any hypothesis test, we will fix the value of alpha. So how much alpha value you will consider, it depends on the situation. In some cases, the type 1 error is more serious. So in that case, we'll consider alpha, very small alpha. And in some cases, type 2 error is more serious. So in that case, we'll consider a small beta and maybe large alpha. Do you have any question? Okay, so now we'll go over some example. For the following hypothesis test, determine the null and alternative hypothesis. Okay, so before doing any hypothesis test, first thing is determine the null and alternative hypothesis. Also classify the hypothesis test as two-tailed, left-tailed, or right-tailed. Then we'll determine the tail of the test. Okay, the mean local monthly bill for cell phone users in this country was $40.57 in 2001. A hypothesis test is to be performed to determine whether last year's mean local monthly bill for cell phone users has decreased from 2001 mean of 40. So in 2001, it was $40.57, the average monthly bill. So that's mean in 2001, the mu was 40.57. Okay, so this is our null hypothesis. And what is the alternative hypothesis here? We want to test whether the last year's mean local monthly bill for cell phone users has decreased. So that's when we want to test whether in last year the mu is greater than 40.57, or we want to test whether mu is less than 40.57. What do you think? Should we write mu less than 40.57 or mu greater than 40.57? Anyone? Less than, right? Yeah, that's correct. because we want to see whether it has been decreased or not, right? So we want to test this one, mu less than 40.57. So since we want to test mu less than this, that means this is left tail test, right? This is left tailed test. Yeah. Do you have any question? Yes, this is less than. Okay, so we'll go over some more example. A study by researchers at a university addressed the question of whether the mean body temperature of an animal is 99.8 degrees Fahrenheit. Among other data, the researchers obtained the body temperatures of 101 healthy animals. Suppose you want to use this data to decide whether the mean body temperature of healthy animals is greater than 99.8 degree Fahrenheit. So here the null hypothesis is the researcher addressed the question whether the mean body temperature is this or not. So that's when the null is 99.8. And alternative is they want to see whether the mean body temperature of healthy animals is greater than 99.8. So that's when they want to test this. Whether mu is greater than 99.8 degree Fahrenheit. So the alternative is mu greater than 99.8. So that's mean this is right tail test. Okay, so another example. Cadmium, a heavy metal is toxic to animals. Mushrooms, however, are able to absorb and accumulate cadmium at high concentrations. So some governments have a safety limit for cadmium in dry vegetables at 1.1 ppm. A hypothesis test is to be performed to decide whether the mean cadmium level in a certain mushroom is not equal to the government's recommended limit. So the government's recommended limit is 1.1 ppm. So now the researchers want to do a hypothesis test to see whether their statement is correct or not. So that's mean the government statement is mu is equal 1.1. And the researchers want to test whether this is equal 1.1 or different from 1.1. So here we want to test mu is different from 1.1. It could be less than 1.1 or greater than 1.1. So that's when this is two-tailed hypothesis test. Do you have any question? Okay. So suppose that in a hypothesis test, the null hypothesis is in fact false. So the true fact is null is false. True fact, and this is our decision. So A is true, A is false. And here reject H0. FTR means fail to reject H0. Okay. So the true fact is the null hypothesis is false. So this is the true fact. Now, is it possible to make a type 1 error? What do you think? Is it possible to make a type 1 error? Yeah, two-tailed, yes, that's correct. So when it is unequal, it is two-tailed. When it is less than, this is left tail. When it is greater than, this is right tail. Yeah, that's correct. Okay, so there is no chance to make any typo error, right? Because the true fact is null is false. So our decision could be reject null. If null is false, if we reject null, that means this is correct decision, right? That means it will be correct decision. And if null is false, we fail to reject null. So that means this is type 2 error. So in this case, we can make type 2 error, but we cannot make any type 1 error here because the true fact is A is not is false. Okay. So we have one more example here. In the US court system, a defendant is assumed innocent until proven guilty. Suppose that you regard a court trial as a hypothesis test with null and alternative hypothesis. So our null is the defendant is guilty. And alternative is, is innocent. Innocent. And here alternative is the defendant is guilty. Okay. So explain the meaning of a type 1 error. So what is the meaning of a type 1 error in this case? So what is type 1 error? Type 1 error is this is true. So that's when the defendant is innocent, right? But our decision is the defendant is guilty. That's the type 1 error, right? So reject null when null is true is the type 1 error. So what we are doing here in type 1 error, we are saying the defendant, we are rejecting null. So that's mean we are saying defendant is guilty. In fact, the defendant is not guilty, right? So this is the type 1 error. So this is very serious, right? If someone is not guilty, but we are say if we make a wrong decision, then the person will be accused as guilty. So this is very serious problem. So part B, explain the meaning of a type 2 error. So what is the meaning of a type 2 error? So the meaning of type 2 error is null is false, but we fail to reject null. So what will happen if null is false? Null is false means the defendant is guilty, right? And we fail to reject null. So that's mean it couldn't prove that the defendant is guilty. So type 2 error means we were not able to prove that the defendant is guilty. In fact, the defendant is actually guilty. Yeah, this is also serious, but the type 1 error is more serious because the innocent people will be accused as guilty. So in this case, we have to consider alpha, very small alpha, because if we consider large alpha, then based on our decision, an innocent person can be accused as guilty. So in part C, if you were the defendant, would you want to alpha to be large or small? Okay, so if you are a defendant, so do you want large alpha or a small alpha? What do you think? So you want, okay, so think about that. If you have large alpha, that means you have more possibility to make type 1 error. And more possibility to make type 1 error means innocent person will be accused as guilty. So that's mean if you are innocent person, you might be accused as guilty if you consider large alpha. Now think about that. Do you still think that you will consider large alpha or a small alpha? Yeah, a small alpha, right? Yes, that's correct. Because you do not want to be accused as guilty, even though you are an innocent person. Yeah. Okay, so that's why the determining the alpha value is very important before doing any hypothesis test. Okay, so in part B, explain the meaning of a type 2 error. So yeah, we explained. So in this case, so even if you consider large alpha, so yeah, it's a problem, but it will not actually harm anyone that much. Yeah, but it is also a problem. But still, if you consider little large, that's okay. So in part C, if you were the defendant, okay, in part D, if you were the prosecuting attorney, would you want beta to be larger or smaller? Explain your answer. So beta is the probability of type 2 error here. So type 2 error means we fail to reject null when null is false. So that's mean we fail to prove that the person is guilty even though the person is actually guilty. So if you were the prosecutor, that's mean you want a small alpha, a small beta, right? Because you want to do the right judgment. So what are the consequences of the court system if you make alpha is equals to 0 and beta equals to 0? Okay, so if you make alpha 0, so then what will happen? So in the context of this question, so what will happen if you consider alpha 0? Alpha 0 means you will not make any type 1 error. So if you do not make any type 1 error, oh yes, sure. Alpha is the probability of making type 1 error. So that's mean the chance of making type 1 error. So if alpha is 5, sorry, alpha is 0.05, so that's mean there is 5% chance that you will make type 1 error. If beta is 0.05, that's mean there is 5% chance that you will make type 2 error. Yeah, alpha is probability of type 1 error, and oh, it's 11:40, right? Okay, so we have 5 more minutes. Yeah. And if beta is 0.05, that's mean there is 5% to make, no, you're fine. There is 5% to make type 2 error. Is that answer your question? Is it clear now? The alpha and beta? Yeah, that's a very good question. Yeah. First, you need to have like clear concept about alpha beta. Is it clear now? Okay, you are welcome. Okay, so what is the consequence if alpha 0? If alpha 0, that's mean you will not make any type 1 error. So that's mean no innocent person will be punished. So what is the consequence of beta equals to 0? The consequence of beta equals to 0 means you will not make any type 2 error. So that's mean all the guilty person will be punished. Yeah. Okay, so suppose that we have null hypothesis. Okay, so actually we discussed similar type of problem, so I'm not going to discuss this one again. Yeah. Okay, so this is the last example for today's class. The recommended dietary allowance RDA of iron for adult females under the age of 51 is 12 milligram per day. So the RDA, they recommend 12 milligram per day under the age of 51 females. So a hypothesis test is to be performed to decide whether adult females under age of 51 are on average getting, whether they are getting less than 12 milligram of iron. So the null and alternative hypotheses are, so the null will be then mu is equal 12 milligram and alternative will be then mu less than 12 milligram. So explain what it would mean to make a type 1 error. So to make a type 1 error means null is true, we'll reject null. So that's mean we are saying that mu is the females are taking less than 12 milligram of iron, even though that's not true. So a type error would occur if in fact mu is 12 milligram, but the results of the sampling led to conclusion that mu is less than 12 milligram. And in type 2 error means this is false, mu is equals to 12 is false, but we fail to reject this one. So that's mean the female are not getting 12 milligram of iron, but we are saying that they are getting. So what explain what it would mean to make a correct decision? The correct decision means so a correct decision would occur if mu is 12 milligram and if we fail to reject the null, and if mu is less than 12 and if we reject the null, that will be the correct decision. Yeah. Okay, so it is 11:43, so I'll stop here today and your quiz will start at 11:45.